turn in right, and then I have a bad grade,
You
and
bet-
the
you
teacher
better-
is mean, and they won't take it, and then I get a bad
Okay,
grade.
but one, that's on me. Two, you better
And
be
my mom
over that
beats
before you go to college.
That's not my fault. I can go to college in class in person.
You'll still have to do a lot of stuff online in college.
Oh no, but I can go to the library and I'll have people around me. I don't like going home and doing something. Nobody's there. Y'all, it's just me.
You can still go to a coffee shop today. All right. So let's start talking about this. I know everyone isn't quite done with number 6. I think most of us at least got to look at number 5. Oh, so y'all haven't started. Really quickly, have we gotten to 6? Show of hands for the groups. Okay. So it'll be okay. We'll still have a conversation. I just know that most of the groups are at 6. Okay, really quickly. So a couple of things to point out, right? We're defining some of these key ideas within the textbook. So in observational study, the data are gathered about a characteristic of the population by simply observing and describing events in their natural settings, right? And so a survey in a way is like that, but there are some differences that we're going to talk about. And so recording the number of children who use the swings at a local park is an example of this. Notice in this setting, did they survey by asking questions of those kids?
Yes. No.
Did they actually ask any questions of the kids?
No.
No, so they're observing, they're not surveying. And so those are things we want to pay attention to. So what is the population, the sample, and the characteristic of interest? This is going to go quickly, but what is the population?
In-house daycare centers.
Did we already do this yesterday?
Yeah.
Thank you. I was like, I feel like we already talked about this one. All right, but we did not talk about number 2, did we? Bless you. Okay. This is something I saw Cameron do that I really like. This is a good idea. What is this called?
Venn diagram.
Venn diagram, right? So the Venn diagram can help us easily see what is just an observational study and what is just a survey. So first things first, what do they have in common?
They're both collecting data.
They're both collecting data.
They're both asking questions.
Okay. Now, when you say they're both asking questions, are you saying like they're both asking questions of people?
Well,
So that may be something that's a little bit different. Where is the question? Where is it about when we ask questions of people? Sample survey, right? So ask questions directly of people. Okay. Anything else?
observational is the characteristic of the population, and sample is the sample data of a population. Is that different?
Trying to think. Aren't we looking at some characteristic no matter what type of study though?
Mm-hmm.
Right? So really I would put there's a characteristic of interest here. That's the reason why we're conducting a study, is because we're interested about something.
Observational would be observing the collective data.
Well, you observe to collect the data. So when we say we observe, we're not going to ask questions, we're just going to what? Watch, right? Okay? So just watching, or literally observing to collect the data. Realistically, those are the only real differences. There's a lot of other things we should put under what they have in common though. What's the goal of an observational study? Nope. Come on, we talked about the goal of an observational study lots of times.
To get a prediction.
To make a prediction about a population. What are you going to do with a survey? What's the goal?
About a population.
Are you going to collect the data for the whole population?
No, just a sample.
So we're going to collect data from a sample and try to what? Oh, so is that something in common? Okay? So the goal is the same. Use a sample to make a prediction about the population. Does that mean there's anything else that might be the same between them?
Mhm.
Like what?
They both are using this sample to.
So let me ask you this, what could prevent the sample from making a good prediction? Why would our sample not be representative of the population?
Bias.
Bias, is that an issue for both types of studies?
Mm-hmm.
Bias is a major issue. There's only one other thing I would add in here. What is the main sampling technique that we discussed that will help us reduce bias?
The randomization.
Random selection, right? Random selection is a huge, huge part of reducing bias.
What thing did we talk about then? Was it on the papers we did? Like the lesson, like the ones we've been doing? We
What?
talked about it on those.
We'll talk about what?
Random selection. So I was trying to find it for my
Oh, for the
my purple
summary?
paper.
So if you remember, when we did the average word length,
Mhm.
y'all randomly selected when you just picked words, but was it truly random?
No.
No. Then we use a random number generator to randomly select.
Okay.
There's also a definition about a random sample within the textbook.
Okay.
I think it's under 1.1. So then we get to this, do we all get the notes down that we need or want? Okay. So then we get to this idea of an experiment, which what are we trying to establish with an experiment?
Cause and effect.
Cause and effect, right? And so we have to apply treatments, right? Those are known as experimental conditions, or how we apply our independent variables to members of a sample, which are known as the experimental units, right? So whenever we say experimental units, it's just people that have the treatments applied to them. Okay? So we got the asthma patient. So population here.
200 asthma patients.
Anyone want to push back on that, or do we all agree that the population is 200 asthma patients? Oh, is that the sample? Why is that the sample? Notice, is that the population that we're trying to make a prediction about?
No.
No. Does that make sense? It's okay, we're learning from it. So 200 asthma patients, that is our sample.
He said that's the sample, not the population.
That is not who we're trying to collect or make a prediction about, that's who we're collecting data from. The sample is who we collected the data from. The population would be
Asthma patient.
all people with asthma. Okay? And also, please remember, I know this is a very unusual concept. It is great to make mistakes. We learn from mistakes because that's when our brain is growing. You will have way more growth from mistakes than when you don't make mistakes. In fact, if you look at the newsletter that I sent to your parents and I sent to you, there's a whole article about that that I linked, and it's a really, really good article. All right, characteristic of interest. Okay, so there is the placebo and there is the medication, and now we go under treatment, but what do we want to make a conclusion or a prediction about? That's about whom we're making the prediction, say again? So the effectiveness of the new medication, right? So what am I trying to predict versus who am I trying to predict about? Who is the population? Characteristic of interest is what? I'm trying to determine the effectiveness of the medication. Alright? So the effectiveness of that medication. So what treatments? Remember, a treatment is the experimental conditions or the independent variables that are at play. What are the treatments in this problem or this scenario?
Placebo and inhaler and unit and inhaler.
I think they're both inhalers, right?
Yeah.
So the inhaler with the medication versus,
Inhaler with placebo.
so inhaler with medication versus the inhaler with the placebo. Now let's clarify really quickly. The placebo just means that there is nothing, no active ingredient, right?
They're just giving them a pill.
So it's basically just an inhaler without medication, is what it is, right? So inhaler without meds. And that is what is creating the placebo effect.
Could that work?
What do you mean?
Like if somebody has like a problem or something and you like placebo.
Very much so. So like, it's a mental thing a lot of times. Remember the whiffed thing yesterday? It was a mental thing when they drank the energy drink that I'm stronger now. They weren't stronger, they just believed that they were, so they tried harder. There are times, especially, and someone brought it up in when I was coming around earlier, with the severity of asthma, that people believe they need an inhaler when they really just need to calm down. And so giving them that placebo will help determine if it's actually, do you need medicine? Because here's the thing, and this is what it might sound cruel that we're giving someone an inhaler without meds, but medication is not necessarily always the best thing for you. So if we can get you a placebo inhaler that just helps you calm down without any medication, that might be better for your lungs long term. Does that make sense? And so like we're actually, and that's the other thing is, what they're trying to study is this new medication actually better? Well, we need to know if the medication is better or if it's just the belief that it's helping. Okay? And so that's going to help us clarify that detail. So some ways the researchers could choose a biased sample. And so what I heard a lot of people initially say is, well, what if they told people whether they're getting the medication or not? But that goes back to the issue of confounding, not the biased sample. What could create a biased sample? And I think I heard actually multiple groups say testing people from one state. Because will that allow you to make a prediction about all of the US or the entire world? No. Now, I do want, I'll come back to that in a second. I think group 4 came up with a really good idea. What were y'all talking about that could create biased samples?
The severity of their asthma.
Okay, so could we end up getting all people that have really bad asthma?
Mm-hmm.
Yes. Could that be different though than the people who have mild asthma?
Yeah.
Mm-hmm.
So it's important to recognize that we may want to randomly sample to get people who have bad asthma and people who have mild asthma. So the severity of asthma. So how we get that, and so how do we get a biased sample? And realistically, I guess, so really if you go under confounding as well, why would the severity of asthma create a biased sample? Well, who's going to be the ones most likely to try to get this treatment?
People with bad asthma.
The people with bad asthma are the ones who are going to volunteer for this, right? You can't force people to take medication. So in this case, people with bad asthma probably volunteer. And notice this key word here, volunteer. So what kind of bias might be at play? Volunteer bias. Is there anything else that anyone else wants to add that we haven't mentioned or want to say, hey, is this a possibility? Going once, going twice. So let's look at number 6. So in the textbook, this is when they first define confounding, right? When there are possible reasons called confounds or confounding variables for the results to have occurred that were not identified prior to the study, right? So suppose one of the treatment groups was given the new medication with an inhaler and the other group was given a placebo with no inhaler. Describe how this design of the experiment introduces a confounding, right? Or a confounding variable. Some of us already kind of hinted at it, the severity of asthma, right? Could we end up getting all the people, or giving all the people with mild asthma the inhaler, and then it looks like it did an amazing job, but people with severe asthma had the placebo, and so it looks like it did a crappy job, right? So under here, we could definitely say the severity of asthma would be a confounding variable. I'd probably put that under number 6. Are there any other confounds that could happen that may not have been accounted for in this experimental design?
We put, you don't know if it's the medication or the inhaler if you took it up. That's why.
But notice they have the inhaler with medication and the placebo, so they're able to directly compare those. Is that what you were trying to say? Say it again.
Since they took away the inhaler, we don't know if the inhaler works or if the medication works.
But they didn't take away both. Placebo with no inhaler. Yes, thank you. I misread that. So in this case, is it the medication versus meds versus no meds, or inhaler versus no inhaler? Right? We don't know which one is at play there. That's a major issue. We don't know what's actually affecting the dependent variable. Is there anything else that could be a confounding variable? What about age? Could the age affect how well someone responds to a medicine or not? Or to a placebo or not? Typically a younger person, unless they have really severe asthma, will be able to recover more quickly or more easily. So that could be something to consider. Thinking along those lines, are there any other features of a person that might confound the results? Say again?
The environment.
Their environment, okay. And that's kind of part of the original question that we saw. Anything else? What about their health? Like their overall health, right? How they eat, how active they are in their life. Could those things affect how the inhaler works? Okay? So that could introduce a confounding. Okay? So I want to point out something like meds versus no meds or inhaler versus no inhaler. Can you easily fix that as a researcher? Yeah, you just make sure they both have inhalers. We go with that idea? Is it easy to fix age, environment, and health though? Is there a way to control that? So what do we do as researchers when there are confounding variables that we cannot control? So we choose randomly with observational studies. We randomly, not pick, assign is the wording we use. Okay? So whenever there are variables that we cannot control, so we say potentially confounding variables, cannot control, so we randomly assign. It is an important distinction to note that we randomly assign treatments. We randomly select a sample, right? Because we're literally selecting, we're taking people from the population and randomly selecting them. Here we already have the people, we are assigning them to treatments. It's an important distinction that I struggled to really understand for a while. There. So let's look back at 3.6. We're going to go over a couple of these together. I know you haven't worked through them yet. We're just going to have to talk about them as a whole class. Yes, ma'am. So, does regularly taking aspirin help protect people against heart attacks? The Physician's Health Study 1 was a medical experiment that helped answer this question. The subjects in this experiment were 21,996 male physicians. Half of these subjects took an aspirin tablet every other day, and the remaining subjects took a dummy pill that looked and tasted like the aspirin, but had no active ingredient. What are they trying to test if there is no active ingredients?
That, the
The
placebo.
placebo effect, right? So is it actually the medicine, or is it the belief that you're taking the medicine that's helping you out? After several years, 239 of the control group, but only 139 of the aspirin group had suffered heart attacks. This difference is large enough to provide convincing evidence that taking aspirin does reduce heart attacks. Why was it necessary to perform an experiment rather than simply asking the doctors whether or not they take aspirin regularly?
Because it would mess up the placebo effect. They have to not know what they're taking to see if it works, because it's supposed to be in your head.
You put a trick in mouth.
Yeah.
Well, yes, but look again at this. Notice they're saying if we'd done an observational study or a survey, we could just ask the doctors whether or not they take aspirin regularly. There would be no placebo in that case. So why can we not just ask doctors whether or not they take aspirin regularly?
Because you don't know how regularly they take it, and like, all the details are supposed to be the same with everybody.
Okay, so we don't know how regularly, what we mean by how regularly they're
Like
taking
what
it,
they
which that
need
would
it
create
for.
what kind of variable?
Bias.
Is the issue bias in this case? Okay, really quickly, I want to point this out. Whenever you look at a study, the very first thing you should ask yourself is, what is the goal of this study?
To see if their medicine works.
Okay, so if the medicine causes or helps you have less heart attacks, right? Are we trying to make a prediction about a population, or are we trying to establish cause and effect?
Cause
So what are we dealing with here?
Confounding.
So why was it necessary to perform an experiment rather than simply asking them? Because what are we trying to do? Right. The very first thing, you might want to make this note to yourself, the very first thing you need to do is identify what is the goal, because that's going to tell you if it needs to be an experiment or observational study. And then we're trying to establish cause and effect, but what issue can prevent you from establishing cause and effect? What is the issue that can prevent you from establishing cause and effect?
Not biased, but that other word.
Yep, not bias, but the other word,
Confounding.
confounding, right? Okay, wanting to establish a cause and effect, but there are potentially confounding factors, variables. What things could prevent you from establishing cause and effect in this case? What aspects about the doctors?
If they,
Take the medicine for something like actually, like there's different pain things.
So could they have other issues that they're trying to take it for?
Yeah.
Yes, if there are other issues that they already have, are they more or less likely to have a heart attack? More likely, right? So the current health, that's a potentially confounding variable, right? So I'm going to identify some potentially confounding variables. And this is why we need an experiment. Current health. Anything else?
Age,
Age, that could be a huge factor. What else?
other medications they take.
Other medications. What else? The environment.
Overall?
Say again.
Oh, no, you're not good.
And when I say environment, that could be like where you live, but it could also be how stressful of an environment you have. Because people who live under high stress, are they more or less likely
More.
to have a heart attack?
More.
More stress, right? So all of these things are potentially confounding variables. And I think Gracie even brought this up earlier. How about how frequently? They take aspirin. Like how frequent is frequent? There's one other big issue here though. Why do they have a treatment where half of the subjects took an aspirin tablet, or the remaining took a dummy pill that looked and tasted like aspirin, but had no active ingredient? The placebo. To see the reaction. So to see, is it the actual medicine or is it the belief that the medicine helps, right? And so that's another confounding variable, right? Is it medicine or belief in the medicine? Those are confounding variables. This last one is the biggest one. This is the reason why we need to test the placebo effect. Look at number 2. Why was it necessary for the experiment to include a control group that didn't receive aspirin?
we have something to compare our results to.
Okay, 1, it gives us something to compare our results to, but why else?
To see if the thing has real effect. Like,
Right. So if the medicine or the belief in the medicine is what's causing this fewer heart attacks, that's the word I'm looking for, right? We need to know if the medicine or just the belief in medicine lowers risk of heart attacks. Please hear me very clearly on this. I know some of us are still writing, but a lot of times, as students, we get trapped into thinking we have to know every single detail. No, you need to know the big ideas that are driving these details. When I have an experiment, what am I trying to establish? Cause and effect. That's the most fundamental thing you gotta know about an experiment. But what can prevent you from establishing cause and effect between independent and dependent variables? Confounding. Everything else within experiments falls out of those two ideas. Big ideas to drive your understanding. Because then we talk about the confounding variables. Then we need to understand the placebo effect. Make sure you understand those two ideas first and foremost. We have to skip 3.7, which was getting back to the anchored putting, but it'll be okay. So just a couple more minutes, sorry about that. Okay. So let's look at these ideas together. So does listening to music improve GPA, right? So this is not what the whole thing is about, but actually, yes it is. What are we trying to maybe establish here?
To see if it improves your GPA.
Okay, so what are we trying to establish? Think about the goals for studies.
Cause and effect.
Cause and effect, or
Confounding.
well, cause and effect can have the issue of confounding, but also when would we want a random sample when we're trying to make a what? Prediction about the population, right? So we could be trying to establish cause and effect, or we could be trying to establish a correlation. More than likely, that questioning is cause and effect, but the way that we conduct the study matters. So get all the students in your statistics class to participate in the study. Ask them whether or not...
Teacher, students off the interruption. When the bell rings, I need everyone to report to their advisory to pick up about 3 or 4 things. Ninth graders, primarily, I know some of you might have forgotten, ninth graders, you're going to be predominantly on the English hallway, that's the 300s.
So don't forget it, here's your
Seniors are
homework.
going to be in the 200 hallway range.
We'll finish up 3.9 or 2, 3.9 when we come to class tomorrow.
In the 400s, that's the math
Thank you.
hallway.